Most of them joined. Can you hear me?
Yes, sir.
Did you finish the last problem? We'll do one more. Similar. So from Eulerian to Lagrangian, we'll just check one more. Then we'll move on to other topic. Did you finish that problem that we were doing last class?
Yes, sir. I got YT value and try to find XT also.
Okay. So where is that problem that we were doing? So it's not. It was not part of that. How come we missed? So I didn't write that. Is it? It is in the lecture 1, is it? Anyway, so we'll just check. We'll try to find some other one more problem. We'll do, and then we'll move on. Okay. So let u equal to. So it's a problem. Problem we'll do one more. Now we do 3-dimensional. So basically, 3 components we give 3-dimensional flow. So let u equal to x plus y plus z plus t. V equal to 2 times x plus y plus z plus t. W is 3 times x plus y plus z plus t. B, the velocity components. In Eulerian. Okay. Find the displacements. Find the displacement of the fluid particle in the Lagrange. So how to solve this is the same way, no? So dx by dt, put u equal to dx by dt, write those differential equations. Similarly, dy by dt, 2 times x plus y plus z plus t. Dz by dt, 3 times x plus y plus z plus t. So how do you solve this one? This system? How do you solve?
We can replace x plus y z x plus y plus z equal to dx by dt minus t. We can replace and combine.
Okay, that is one thing. So yeah, you can get 2 equations, right? In that case. So or you add all of them first. So there are 3 equations you need, no, to get x, y, z. So I am just adding all of them so that you get dx plus y plus z divided by dt equal to, this is 6, right? 3, 4, 5, 6. 6 times x plus y plus z plus 3t. So basically you have linear equation here, x plus y plus z. So you solve this, x plus y plus z equal to x of t, basically x of t, y of t, z of t sum you are getting. So you will get some function, okay? Some function of, what do you get? Function of t and c1, right?
Yes, 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 sir.
C1 and t.
Yes,
You call
yes,
this
sir.
C1 and t.
Relate x plus y plus.
And you use this one. So for example, you substitute. So if you do put x plus y plus z here and you substitute here in the second equation, then you'll get dy by dt equal to 2 times dx by dt minus t plus t, right? So this will give me d dt of y minus 2x, so equal to minus t. So this is another equation. So this will give me y minus 2x, y of x minus 2 of x, y of t minus 2 of x of t equal to some another function. So let's call this f1, this is f2. So that's f2 of t c2 comma t. Okay, so this is the first order equation. No? So you have, this is equation 1, this is equation 2. Similarly, just substitute dz by dt. So dz by dt equal to 3 times dx by dt minus t plus t. So this will give me dt of z minus 3t, 3x, right? Z minus 3x equal to minus 2t. So this you solve it to get z minus 3x equal to some other function, some function of t you will get. Okay, solve it. So you'll get function of 3 with constant. Integration constant will give me this one. So first start. So this is your 3 equations. So let's consider initially at some temperature, at some point, right? So x, y, z. Let x, y, z, x equal to x of 0, x of 0 equal to x naught, y of 0 equal to y naught, z of 0 equal to z naught. Be the initial point. So if you use this one, it will fix your C1, C2. Okay, then fix your C1, C2, C3. Then you will have x naught, y naught, z naught, right? And then solve 1, 2, and 3 for x of t, y of t, z of t in terms of what? If you solve
Terms
it,
of t and x naught, y naught, z naught.
yeah. So in terms of x naught, y naught, z naught, and t, right? That's all. That's what is
Yes, sir.
exactly. So you do whatever remaining calculations you please do. Okay. So that's how you get your
Okay, sir.
Lagrange equations.
Okay, sir. Okay, sir.
So next we will see um, so we'll define what is pathline, streamlines, and streaklines. Okay, pathlines. So what is pathline? Simply just like a Lagrangian approach, you just follow a particle. Okay, so if you do that, dx by dt equal to u, right? So x of t you follow, x of t, y of t, z of t, and you take the derivative, that is nothing but your the velocity component, d y of t by dt equal to v, d z of t divided by dt equal to w. So if you follow this x, y, z, the particle, okay, so x of t, y of t, z of t, just by solving these equations, you will get your u of x of t, right? So u of x comma y comma z comma t. Okay, so basically u means so velocity components can be given like in the Eulerian system also. So you can get your u of x, y, z, and t. Similarly, v is also u, v, x, y, z, and t. Similar w also x, y, z, and t. So like this, if you given, so try to simply solve for x, y, z, t. So basically, so whatever you are doing just now in the Lagrangian system is basically x, y, z That is your path lines. Okay, XYZ for t greater than 0. So it's called path line. Path line of the particle with initial position at x at 0, y at 0, z at 0. Okay. So what is streamline? Streamlines. Streamlines are basically, see, what you are doing is path line is basically you are observing over time. So you look at the particle and you just follow it. So over a time, just look at its path as t goes to as t greater than 0. So next every time, so you start with the position x0, y0, z0, and you look at t greater than 0. So exactly that particular path of the particle is basically your path line. Okay. What about streamline? Streamline is basically what you do is you look at the overall body of the fluid and you fix certain time. You fix your time, and you know these you have to look at the velocity vectors. Okay, so if you look at the velocity vectors, directions of the velocity, for example, so streamlines are lines, the curves whose tangents gives the direction of velocity. Do you understand? So you consider a body, you see, at every point at a fixed time, fixed t, in any particular instant, this may be, the flow may be going like this. So this may be going like this. These are the velocities. You're just everywhere, you're writing the velocities. Okay.
Streamlines are those curves whose tangent at every single location have the same direction as the velocity vectors of the flow. We used this definition and streamlines of steady flow, meaning the streamlines that don't change over time, to derive Bernoulli's equation in the previous 10-minute lecture video.
So what are the curves? You just draw a curve parallel,
linked in the description below. Today we will
touching these arrows. These are the lines. Okay, these are the lines. Maybe converging.
Study flow lines. Okay, we will look at these streamlines in a bit more detail, as well as pathlines and
those are your streamlines. Okay, so generally, so they don't cut. Okay, so we just wrote like that. So simply you have a direction. So each one, those are the streamlines. Okay, just think of fixed time. You draw the line. Those are the curves at which you give the direction of the velocity. This is your Q. That is basically UVW. Okay, the direction of the UVW vector at every point. That is what is your streamline. So what is the difference? So how do you write this? So basically dx by dt. So that means dx and u are parallel. So you don't worry about time here. So dx by u, they are parallel, and similarly dy by v, and similarly dz by w. So you solve this one to get streamlines. Okay, so can you see the difference? So fixed time, so there is no, so you're actually following the time for all times you're watching one particle. Those are path lines. At every particle, if you look at it, those are the path lines. But any fixed instant of time, you just look at its some curves whose tangents are the these velocity vectors. Those are your streamlines. So for steady flows, these two are actually same. Okay. Any question up to here? So there's something called streakline also. Okay, streakline. Streak or streak? What do you call? Streakline or streaklines?
Streakline, sir.
Streaklines. So you say these streaklines. Basically, what you do is you have to first understand. Okay, so you look at the one point in the fluid. Okay, so you initially, let's say this is the point. Let us say x naught, y naught, z naught. So through this point, fluid is moving. Okay, it is like through this the fluid is moving. So this is one particle comes out of it. Let us take a path like this. Okay, at time t, you have some. This is the particle. Okay, so before that, now you're watching at t, right? So at time t, that one particle is here. So behind there may be other particles, right? Also coming from the same point, x naught, y naught, z naught. Okay, if not this one, you can take the one particular portion of the fluid through which whatever, something like a nozzle. Through the nozzle, you are watching all the particles. Okay, coming out of the same point. So through this point, it's coming. It's here. So it is time. Let us say after 1 minute you are here. Okay, one. So after 1 minute you are here. Within that 1 minute, there may be many particles coming out of this, right? So they are also going maybe some other direction, right? So it may not travel at the same time. So by the you're looking at this one. Okay, at this may be different times. Just coming out. So those points, if you put them together, those are called streak lines. You understand? So this is a little confusing. So so in generally for steady flows, okay. So for steady flows, all these lines coincide. All these lines coincide. Coincide C or S. Okay, so they are same. Okay, all these lines are same. Followed?
Yes, sir. Sir, can you
Yeah. No. See.
again explain what is steady flow, sir?
Steady flow. Yeah. Steady flow means it doesn't. So you for all times there won't be any change. Okay, so it doesn't change with time. The velocity components or whatever, acceleration, whatever you take, they may constant velocities. It doesn't move with time.
Okay, sir. Okay,
So
sir. Thank you, sir.
U, V, W, for example, U only depends on X, Y, Z. V is only depending on X, Y, Z. W is only depending on X, Y, Z. Is basically steady flow. Okay, so does not depend on time. So what actually happening is you simply look at this pathline. Pathline, you are watching one particle just moving here. Okay, something like this. Now streamline, if you look at it, it is actually you are basically looking at that flow is also looking like this only, because it doesn't change with time. So you get the same line. Pathline, streamlines are same. So what happens here? So if you actually look at the streak line also, what you do is you see this is the one, right? So let us say this is coming. So immediately there is it doesn't change with the time. So whatever part is follow the same. So it may be coming here, right? The behind some point, so at time t, initially zero time, x naught, y naught, z naught. That particle after time t, it is here. So between 0 to t, there is one more particle. Just say, let us say that came out. That is also following the same path because it doesn't change with time. So it is going to be here. So behind that one more, behind that one more, behind that one more, whatever comes. So you see that it's take the same path line only, it will be lying. These points. Suppose it changes with time. Whatever the next particle may take a different path. Okay? Different path at time t. because it enters not at 0, no? Second particle will enter at 0, greater than 0 time. So at time t, so that means t minus that whatever enter time t1, t minus t1 time, you look at its path it's here. And similarly, the third particle t2 time, which is after t1, okay, which is greater than 0. So t minus t2 time, it is going to be here. So you collect all these particles, that is actually streakline. In the case of steady flow, you will see these points actually won't go outside this line, this path line. So it will be coming like that. That's why the meaning of streak lines. So that's why streak lines, all these lines are same. So streak line for steady flows. Unsteady flows, for example, you release some smoke. You see, when you release the smoke, no. So at one point, if you observe, one particular path, it will take another path. So through the same point, it may take another path. Okay.
Yes, sir.
So this is your streak line. So what happens to the streamline? Streamlines is only you don't look at anything, only at particular one time only. There is no time here for the streamlines. Streamlines at a particular time you are watching the full fluid, all its directions of the velocity field. So those lines are basically your streamlines. Path lines are connected with streak lines because you are looking at time. Over a time you are watching particles. Okay, so streak lines, what happens? All the particles that you are watching is only passing through only one point or a group of a small nozzle kind of thing. So some element of fluid element. Okay, so let's take something like this small element. All the particles coming out. Those are stream. You can say, what do you call this one? So whatever comes here, right? So this one stream tube, you can say streak tube. This is a kind of all particles. If you look at it, you consider all those streak lines, put them together. So those are all tube. You can say call it tube. Okay. So you don't worry. So you consider this small thing as a small fluid element instead of just take one point. Through that point, if it is coming, then you just understand that one. So through a point, if it is just coming, if it is a steady flow, it just follows the same path. But it's like uh, somebody is coming and behind us, it's a queue. It's a queue of points. Basically queue. Basically these are the points they're coming through this as a queue. Everyone is entering through this. They follow certain same path. If they follow, and you collect all the queue, all those people who are coming in the queue, no. So just connect them. So that is what is your streak line. So if they take the different path, okay. So second guy may follow different path. By the time you observe this fellow, first fellow, at the same time is here. At the same time, you look at that same time you look at this fellow. It will take less time to come here. Okay. And similarly, this fellow will take less time. So he may be here. You may be taking wrong route. So finally, you connect all those people. So those are your streak. So streaking, right? So some kind of that's inorganized way they're just moving. So if you collect all of them, those are all streak lines. So mathematically, how you are going to do is important. So this is the physical thing. So path lines anyway you can do. That's what you have done already, right? Just now what you did is that path lines only, right? So Lagrangian thing is basically your path lines. Lagrangian, so Euler into Lagrangian that you have done, those are actually your uh, path lines. Okay. But streamlines, you will have to solve something like this: dx by u, dy by v, dz by u. So this system of ODEs you have to solve in terms of x, y, z only. So at a fixed time. Okay. So t is fixed there. So that is the difference. Okay. So how do we solve this one? So if you do the streamlines, another way of looking at the streamlines is we can do just a minute. So how do I look at the other? How do you calculate this one? So this streamline. Another way of looking at is, see this UVW, right? So UVW are parallel, right? UVW are parallel. So the cross product with dx, dy, dz, right? That is basically dy, dz, dz means dx, dy, dz. Okay. So is that's like your dr, dx by dt, dy by dt, dz by dt. So this is equal to 0. So you consider this, you will get your equations. Basically, that will actually giving you. So this is your velocity vector, and this is your tangent to the streamlines. Okay, streamlines the curve whose tangents. No, this is basically dx by dt. If you put it, dx by dt, dz by dt. These are your tangents. Tangent to your streamlines. This is your tangent, and this tangent and your velocity. Okay, so velocity here both are coinciding. So cross product is 0. That will actually give you this one. So you try to solve. How do you solve this system of equations? So to find streamlines, mathematical method is to solve simultaneous equations dx by u and dy by u, v and dz by w. So w, u, v, w are all functions of x, y, z. Okay, because at a particular instant, fixed time only you're seeing, right? Fixed time, at fixed time t, u is given as only u is u, v, w are functions of x, y, z. Do you understand? Hello.
Yes, sir.
Okay, so you try to understand the difference. So for unsteady flows, for example, keep in mind some diffusion process in some fluid, or in the air you open some smoke particles. If you follow, they go different ways. So streakline is different. The streamlines may be different. Overall, at particular instant, if you see exactly what is the flow, you connect all those streamlines. And path lines are basically the particles, particle paths. They may be different. They may cut each other, but streamlines don't cut each other. So I wrongly draw here, because so here in the here I actually put it together. So this they don't actually cut. Streamlines don't cut. Okay. So you overall the whole body is moving, no? So streamlines don't cut. They may be narrowed down, but they don't cut. Okay. So whatever that you have to understand. But streamlines, streaklines can cut each other. Can you see that one? Physical feeling. Streamlines don't cut, but path lines and for example, some path lines. What is this one? This path lines, for example, path lines. You take see one particular line may go like this, and another one is coming. It may go like this. These are path lines. Okay, because these are not steady. Okay. So this is one. This is for unsteady flows. It's possible. Similarly, this is your streak lines. Streak lines anyway. So streak lines can be different path lines. Those endpoints, different times. If you collect whatever comes. Okay. So for example, this particle at T1, this particle at T2. Okay. So this is at 0, T1, T2. Okay. So by the time it reaches here, this point, this will be T minus T1. So here, this is T minus T2. T2 time it reaches here. T minus T1 time it reaches here. 0, when it 0, the particle that enters at T equal to 0, that enters, that becomes here after time T. This is it. It's basically T minus 0. T minus 0, T minus T1, T minus T2, and so on. Okay, collect all those, a trace of those particles coming through this. Okay, so now mathematically, so now we understand how to calculate. So okay, let's look at this mathematically. to find streamlines, mathematical method is to solve this one. This can be done by method of grouping. Have you done any time in mathematics PD ODE solving? Method of grouping, okay, or method of multipliers?
Yes, so like combine, like
Yeah,
so combine dx plus dy something
exactly.
like that.
So you group it. For example, you group it. Suppose you can integrate. You will get like that. Suppose I group these two. Okay. So if you group them, then you may get, for example, x plus y equal to some constant. Okay. C1. Similarly, if you group this one, y plus z equal to another constant. So what are these two? These two are like surfaces. Okay. This is one surface. This is another surface. When you group, you may be grouping all of them together. So x plus y doesn't matter. It's in space, surfaces, surface in space. Okay, surface in space, surface in space. So two surfaces cut in space, basically in lines, right? So those are your x, y, z, x of t, y of t, z of t, or x, y, t. So put them together. So together is basically represents a line, solution line. Okay, so those are actually your streamlines. So method of grouping is look at each group and try to do. So method of multipliers is something like this. So the second method is we will try to solve some problems for you. So dx by u equal to dy by v equal to dz by w. I am trying to look for some coefficients here. P, Q, R or alpha, beta, gamma. So alpha u plus beta v plus gamma w. Okay. So that you have alpha dx plus beta dy plus gamma dz in the numerator. Suppose I make this as 0. I choose my alpha, beta, gamma in such a way that this quantity is 0. Denominators, I make it 0. So this quantity is finite, right? dz by w. So similar all these things. So this cannot be like 1 by 0. Some finite quantity by 0. So it has to be like 0 by 0 form. Okay. This has to be 0 form. That means this also has to be 0. So implies you're getting a differential equation something like this. Beta dy plus gamma dz equal to 0. So you solve this one. Just integrate d of something. So it will give you integrate to get a surface in space. So like that, you look for only 2 such surfaces. So method of grouping may work once, and you may not be able to get one more group to easily solve those differential equations. Okay. So in that case, what you do is you try to look for this method of multipliers. I'm looking for multipliers, alpha, beta, gamma. So alpha, beta, gamma are multipliers. Okay. So you can look for many alpha, beta, gammas, that many number of surfaces you may get. So you need only 2. Okay. 2 such surface C1, C2 are arbitrary constants. So that will give you curves, whatever you want. So it's a parameter, 2 parameter family of curves means basically the C1, C2. So or just remove one C1, C2. So basically together means what? You get rid of, you put it as some C2 equal to function of C1. That is actually a curve. Or just don't worry about it. This is each one is like f of x, y, z equal to 0. That is like a surface. You know that, right? Yes.
Yes, sir.
How do you represent?
Yes, sir.
How do you represent surface?
There
So let me write it. So z
are 2
equal to,
parametric curves, sir.
yeah, this is same as z minus f of xy equal to 0. So this whole thing is looking like f of xyz. So this is called explicit surface. This is called implicit surface. So as you see this form, if you see that one, once you solve, no, is equal to constant, that C1. Different constants may get parallel surfaces. So you consider 2 such surfaces, independent surfaces. So you have 2 independent surfaces. Basically, the whole idea is that you get 2 method of grouping. These are 2 independent surfaces. So you 2 independent surfaces means they obviously cut, right? Dependent means what? They are parallel. So even if you take both of them, you don't get anything. Either they coincide with each other or they are parallel. They don't cut anywhere. So you don't get anything. So only empty set. So they should be linearly, basically independent. So they are independent means they are not parallel. So if they're two are not parallel means they cut somewhere. So that will give you curve. So that is actually your solution of your. That is basically your streamline. Okay, these are the methods. Maybe I will try to do some simple example right now. Okay, so let me do some simple example for you. If you tell me it's not required, I will not do. So it's up to you. Shall I do?
Sir, give.
Huh?
Yes, sir. Yes, sir. Give one example, sir. Yes, sir.
Yeah,
One example.
I'll do.
Okay.
Just give it.
Thank
I have PD book. Yeah.
you, sir.
Mm, the PDs. Where is the PD? Okay, so I'll give you. So let's look at some examples. Examples to solve streamlines. Okay. For examples, you have a dx solve dx by u square y equal to dy by u square x equal to du by y square x. Here u is basically your z. Okay, so basically u component. So if you don't get confused, here u is your z. So let me do it here as z square. Okay, so z square x. So this is your z square x. This is your z. Okay, so let me write it as dz z square x. So this is what is the simultaneous differential equations. For example, this is your z square y is your u component, velocity component, and z square x is your another v, and y square x is your w component, velocity component. So this is how you get your streamlines. Okay, these are the streamlines. Solution of this basically gives you streamlines. For example, how do you solve the now method of grouping? Z square will go. I'm going with only xy. I'm left with only. So if I consider this grouping, okay, so z square x. So let's look at this grouping. Method of grouping I am applying. So if you do this one, z square, I can cancel it. So what you have is dx minus y dy equal to 0. So this means what? It's simply x square by 2 minus y square by 2, right? You should integrate. If you integrate, basically both sides you integrate x dx, y dx. X and y are dummy, so you'll get this one equal to constant c1. So what you are getting is x square minus y square equal to, you observe this is anyway arbitrary constant, so you observe them. So this is one equation. So now I can get rid of x in this grouping also. Okay, so if you do this one xx, if you remove it, you'll get y square dy equal to z square dz. There's no x I got rid of in these groupings. So if you do this one, y cube by 3 minus z cube by 3 equal to c2. So what you are getting is y cube minus z cube equal to c2. So this is your another surface. These are the surfaces together will give you your stream function. Okay, so together gives streamlines. Followed? So this is the method of grouping that you do. So together equations, these two, whatever bracketed equations, those will give you for certain c1, c2 values. Obviously they are different, right? So they are not parallel. So x square minus y square looks like some hyperbola, and this y cube minus z square is some nonlinear curve. Okay, so You don't worry. So that is your method of grouping. So if you apply, so sometimes method of grouping may not work. So in that case, what you do? For example, I give you simple another example where this is one. Okay, so this is one. So let's look at another example. So another example, if you write, so example 2 is, let's say dx by solve the simultaneous equations, dx by x into y square minus z square equal to dy. If you have done first order PDEs, you might have encountered these equations. Have you done? Have you solved any time?
Yes, sir. Yes, sir. Last semester, sir.
So these are the two. This is how you solve this one. This, if you get it, so whatever is together, those surfaces are your streamlines. Okay. So for example, see here, now can you make a grouping so that you know it works? No, right? Any two of them, if you pick up, you
Yes, sir.
cannot get rid of that Z. So you need to, the only way look for is method of multipliers. Okay. The only way is to get multipliers. So what is the multipliers that you have to look for? So you collect this into this, some constants. Constants is better. You may get some simpler functions. That is also okay. Okay. So I am just giving you here so that you know that you have to think. So that's the skill that you need to have. So one multiplier is basically xyz. xyz is one multiplier. Since why the reason is x into this one, so that will give you x square y square minus z square plus minus, you have minus, right? So that is y into minus y, so that's why minus y square, z square plus x square, and here plus z square into x square plus y square. So if you look at this is actually 0. Okay, so implies this is a multiplier. So that is one multiplier, means you have obviously x dx plus y dy plus z dz divided by 0. So that means this has to be 0. Okay, so that means x square by 2 plus y square by 2 plus z square by 2 equal to constant C1. So this is one surface I get. What are this? These are your spheres. Okay, simpler case. What is the other multiplier you can think of? Can you think of other one? So I'll just give it. So you may look for some other thing if you want. Okay, so let me see here 1 by x and minus 1 by y and minus 1 by z also will work. Is also another multiplier.
Yes, sir. Yes.
So as you see this, if you calculate, if you remove it, so you'll get 1 by x means y square minus since y square minus z square minus z square minus x square. Okay, here plus and again minus x square minus y square. So you see everything gets cancelled, right? So somewhere I think you made a mistake. 1 by x minus plus, right?
Yes,
So
sir.
minus that makes it plus. This will be plus. So you have everything at 0. This is equal to 0. So this implies dx by x minus dy by y minus dz by z equal to 0. So this will give me, now I can just integrate one by one. So ln x minus ln y minus ln z equal to ln c2. So if you say this one, so this is actually x divided by yz equal to c2. So this is your new surfaces. Whatever it may looks, but obviously these two are different. So these two bracketed, whatever we rounded, so those are two surfaces, they cut each other. So that is actually streamline. Okay. So solve, not solve. So together. So together means how do you get rid of? How do you get rid of this one? So two surfaces.
So do you write f of C1 is equal to C2?
C1 equal to C2. If you put it, you can't. No, you can't put no. So see.
No, f of C1 is equal to C2.
See, I have f of xyz equal to C1 and g of xyz equal to C2. So this represents a curve in space, right? So how do I see? How do I get that curve? Two surfaces. When you are given two surfaces, so how do you see this one? So you have to see how do you see this one? Do you know any method? Yes.
No, sir. No, sir.
So think about it. Okay. So this together will represent a curve. Okay. This together represent a line curve in space. So you just see how we find that. So we'll see maybe tomorrow. Okay. So this is the method to
Maybe,
find the
sir.
streamline.
Maybe there where these two surfaces cut each other, that
Uh,
represents a curve.
yeah,
Then
but mathematically, how do you cut? For example,
then
sphere you take, plane you take. Plane, if you are taking, for example, simple. You
then then
imagine there is a sphere and there is a plane. Okay. So what is that you do? So here plane means x plus y plus z equal to something. So that you replace with something.